What if, beyond the stars, there's a boundary we're destined to cross? An edge so far away, it feels like the ultimate frontier. But here's the question that has stumped humanity for centuries. Does such an edge even exist? To answer this, we need to start with how we define the universe itself. What we call the observable universe is not the whole story. It's merely the slice of reality we can see, dictated by the speed of light and the time since the Big Bang. Light from beyond 13.8 billion years simply hasn't had enough time to reach us. But does that mean there's an edge? Or are we just staring at the limit of our own cosmic horizon? Now, here's where it gets even stranger. The universe is expanding, and not just at a leisurely pace. It's expanding faster than the speed of light. Yes, you heard that right. Entire regions of the cosmos are receding from us so quickly that their light will never reach us. Imagine running on a treadmill that speeds up faster than you can move. Are we chasing something we can never reach? This rapid expansion means the observable universe, the part we can see, is only a fraction of what might actually exist. Beyond this visible boundary, there could be galaxies, stars, and uncharted realms we'll never know. But back to the big question. Is the universe infinite, or does it have an edge? Surprisingly, both could be true. Some theories suggest the universe might be infinite, stretching on forever with no boundary. Others propose it's finite but without edges, like the surface of a balloon. You could travel in one direction and eventually end up back where you started, without ever finding an end. This idea of a finite but unbounded universe is one of the most mind-bending concepts in cosmology. Still, even with all our advanced telescopes and scientific breakthroughs, we don't know what lies beyond the observable universe. Is there more? Space? Different physical laws? Or perhaps nothing at all? Can you even imagine what nothing looks like? The idea of nothingness itself defies our understanding. It's not darkness, emptiness, or void as we know it. It's something far stranger. So, when we talk about traveling to the edge of the universe, we're grappling with a paradox. Are we venturing toward an actual boundary, or are we exploring the limits of our understanding? What do you think? Could there be a final destination waiting for us? Or is it a journey with no end? Let us know your thoughts. And if you're curious about what might happen if we could actually make this journey, stick around, because things are about to get even more mind-blowing. Imagine stepping into a craft that could slice through space-time itself. What would that feel like? To embark on a journey to the edge of the universe, we'd first have to confront the sheer scale of the cosmos. The edge of the observable universe is 46 billion light-years away. Even if we could travel at the speed of light, a feat currently impossible, it would take us 46 billion years to reach it. And here's the catch. By the time we got there, the universe would have expanded even further, putting that edge perpetually out of reach. So, how could we even dream of making such a journey? Let's start with current technologies. The fastest spacecraft humanity has ever built, the Parker Solar Probe, zips through space at a blistering 430,000 miles per hour. At that speed, it would take over 70,000 years just to reach the nearest star, Proxima Centauri, let alone the edge of the universe. Clearly, traditional propulsion systems aren't enough. We'd need a revolutionary leap in technology to even begin considering intergalactic travel. This brings us to some of the most mind-bending concepts in physics, like warp drives and wormholes. A warp drive, theoretically based on the Alcubierre drive, would allow us to bend space-time itself. Instead of traveling through space, a warp drive would compress the space in front of the ship and expand the space behind it, creating a kind of space-time bubble that moves faster than light relative to the outside universe. While this idea sounds straight out of science fiction, it's rooted in Einstein's theory of general relativity. The problem? Creating and sustaining a warp bubble would require enormous amounts of exotic matter, something we haven't even proven exists. Then there's the idea of wormholes, shortcuts through space-time that could connect two distant points in the universe. Imagine stepping into a tunnel near Earth and emerging billions of light-years away in moments. Wormholes are theoretically possible, but they come with their own challenges. They'd likely be incredibly unstable, requiring advanced technology to prevent them from collapsing. And even if we could stabilize one, navigating through it without being torn apart by intense gravitational forces is a whole other problem. But is faster-than-light travel truly possible? According to the laws of physics as we know them, nothing can move faster than light within space-time. Yet some theories suggest ways to cheat this rule. For instance, quantum entanglement allows particles to communicate instantaneously over vast distances, hinting at possibilities we're just beginning to understand. Could future breakthroughs unlock new ways to traverse the cosmos? Even with these ideas, the journey to the edge of the universe presents challenges that are almost unimaginable. The energy requirements alone would dwarf anything humanity has ever achieved. And then there's the question of time. How would a crew survive the vast timescales involved? Would we need to send robots? Or could humans hibernate through millennia of travel? The journey to the edge of the universe is, for now, firmly in the realm of speculation. But imagining the possibilities pushes the boundaries of our knowledge and inspires innovation. Could we one day step into a craft capable of bending space-time, slicing through the universe as easily as cutting through water? If that day ever comes, we won't just be traveling through space. We'll be redefining our place in it. What do you think? Could such a journey ever become a reality? Let us know your thoughts as we move deeper into the mysteries of the cosmos. Could we find entire galaxies colliding or stars being born as we pass? Imagine stepping into a spacecraft capable of crossing the universe, and as it begins its journey, Earth fades into the distance, a blue speck swallowed by the vast black ocean of space. The first leg of the journey would feel familiar. We'd pass by the planets of our solar system, skimming past the red deserts of Mars, the swirling storms of Jupiter, and the icy rings of Saturn. But beyond Neptune, where the sun becomes just another star in the sky, the true adventure would begin. As we leave the solar system behind, we'd traverse the interstellar void, an emptiness broken only by the occasional glimmer of distant stars. Eventually, we'd reach the edge of our galaxy, the Milky Way. From this vantage point, we'd see the spiral arms of our galactic home, glittering with billions of stars. Some would be surrounded by glowing nebulae, the birthplace of new stars, while others might flicker near the end of their lives, collapsing into dense neutron stars or black holes. Continuing outward, we'd encounter strange phenomena that defy our understanding. Imagine passing by a quasar, one of the brightest objects in the universe, powered by a supermassive black hole at the center of a distant galaxy. From millions of light-years away, its light would outshine entire galaxies, radiating with a power so intense that it seems almost supernatural. Moving further, we might encounter a galactic collision. Two galaxies merging in slow motion, their stars flung into new orbits, and their cores spiraling toward an eventual cosmic dance of black holes. The farther we travel, the stranger the sights become. Nebulae like the Crab Nebula, with their vibrant swirls of gas and dust, would stretch across the sky like cosmic paintings. We might pass rogue planets, worlds untethered to any star, drifting through the dark like cosmic wanderers. And as the density of matter decreases, we'd begin to notice the vast emptiness of the intergalactic medium, where light from nearby galaxies becomes faint and scattered. As we approach the edge of the observable universe, the light we see would tell an ancient story. Galaxies here would appear smaller and redder due to the expansion of the universe. Their light stretched over billions of years. These galaxies existed when the universe was young, showing us a glimpse of what the cosmos looked like near its birth. Imagine looking out the window and seeing not just space, but time itself, watching the universe rewind to its earliest moments. And yet, even as we approach this distant boundary, there would still be mysteries beyond our sight. What lies past the observable universe? More galaxies? Entirely different physical laws? Or perhaps something we can't even imagine? The journey to the edge of the universe isn't just a journey through space, it's a journey into the unknown, where every step reveals wonders that challenge our understanding of reality. So, what do you think you'd see along the way? Would the universe reveal its secrets, or leave us with more questions than answers? Share your thoughts as we move closer to uncovering what might lie beyond this cosmic frontier. What if we're looking at the cosmic equivalent of an ancient photograph, a snapshot of time itself? As we reach the edge of the observable universe, we encounter something extraordinary: the cosmic microwave background, or CMB. This faint glow of radiation spread across the entire sky is the oldest light we can detect. It's not just a random signal, it's a relic from a time when the universe was only 380,000 years old. To put that into perspective, if the universe's entire history were compressed into a single year, the CMB would represent the first, few hours after midnight on January 1st. The CMB is like a baby picture of the cosmos, showing us what the universe looked like in its infancy. Back then, the universe was a dense, hot plasma of particles and radiation. Light couldn't travel freely. It was trapped, bouncing endlessly between particles like photons in a fog. But as the universe expanded and cooled, it reached a critical moment called recombination. Electrons and protons combined to form neutral hydrogen atoms, and the fog cleared, allowing light to travel freely for the first time. That light has been traveling through the cosmos ever since, stretching and cooling over billions of years as the universe expands. Today, we detect it as the CMB, a faint microwave signal that holds the secrets of the universe's beginnings. Studying. The CMB has revolutionized our understanding of the cosmos. It's not just a pretty picture, it's a treasure map of the universe's structure and history. Tiny fluctuations in the CMB's temperature reveal the seeds of the galaxies and galaxy clusters we see today. These fluctuations are like fingerprints of the Big Bang itself, showing us how matter clumped together under gravity to form the cosmic web that spans the universe. Without the CMB, we wouldn't have the detailed understanding of the universe's origins that we do today. But the edge of the observable universe is more than just a glimpse of the past. It's also a frontier of unanswered questions. The CMB represents the limit of what we can see, the point beyond which the universe becomes opaque. What lies beyond it? Could there be other relics of the Big Bang waiting to be discovered? And what does this ancient light tell us about the universe's ultimate fate? These are questions scientists continue to explore as they study the CMB in ever greater detail, using advanced telescopes and satellites to peer deeper into the cosmos. Standing at the edge of the observable universe, we are reminded of how far We've come in our quest to understand the cosmos. From this vantage point, we're looking at a frozen moment in time, an echo of the Big Bang that shaped everything we know. But it's also a reminder of how much we still don't know. Beyond this ancient light, there could be entirely new realms of physics, dimensions of space, or phenomena we can't yet imagine. What do you think? Could the CMB be the key to unlocking even greater cosmic mysteries? Let us know as we prepare to dive into the final chapter of our journey to the edge of the universe. What if the edge of our universe is just the beginning of another, stranger one? Standing at the boundary of the observable universe, we face a profound and thrilling mystery. Beyond the edge of what we can see lies the unknown, a realm that may defy everything we think we know about space, time, and reality itself. What could be out there? Is it the end of the universe? Or is it the gateway to something far greater? One possibility is that beyond the observable universe, space simply continues. Imagine an infinite expanse of galaxies, stars, and planets stretching forever beyond the reach of our telescopes. The observable universe, then, would be just a tiny bubble in an endless cosmic ocean. This idea fits well with the theory of cosmic inflation, which suggests that the universe expanded exponentially in the moments after the Big Bang. If inflation occurred, it might mean the universe doesn't just continue. It could be infinitely large, with no edges, boundaries, or stopping points. But what if it's more complicated than that? Some scientists propose that what lies beyond the observable universe isn't just more space, but entirely new universes. This is the concept of the multiverse, a collection of parallel universes that exist alongside ours. In some versions of the multiverse theory, every choice you make creates a new reality. Did you take a different path in life? Somewhere, in another universe, you did. These alternate realities could differ slightly, or they might follow entirely. Different physical laws. Could the edge of our universe be the point where one reality connects with another? Another possibility is that space and time themselves loop infinitely. Picture walking in one direction forever, only to find yourself back where you started. This closed universe model suggests that the cosmos might be finite, but without edges, much like the surface of a sphere. If this is true, then traveling to the edge of the universe might simply lead us back to where we began, like a cosmic Mobius strip. And then there's the truly mind-bending idea that what lies beyond the observable universe is something we can't even comprehend, dimensions or realms that exist outside our current understanding of physics. Imagine a plane of existence where time flows differently, or where space itself folds in ways we can't visualize. Could there be intelligent beings out there, operating in ways we can't perceive? Could there be entire realms of matter and energy that make our universe seem small by comparison? Speculating about what lies beyond the universe isn't just a scientific exercise. It's a way to explore the limits of our imagination. The idea of the multiverse, infinite space, or looping time challenges us to think beyond what we can see or measure. What if the edge of our universe isn't an ending, but a beginning? What if it's the threshold of an interconnected web of realities, each as vast and mysterious as our own? The possibilities are as endless as the universe itself. So, what do you think lies beyond the edge of the observable universe? Infinite space? Other dimensions? A multiverse of alternate realities? Let us know your thoughts, and if you enjoyed this journey, don't forget to like, share, and subscribe for more explorations into the unknown. Because out there, beyond the stars, the adventure is just beginning. Would reaching the edge mean the end of the universe, or just the end of our understanding of it? As thrilling as the prospect of traveling to the edge of the universe might be, the journey itself could be fraught with dangers so extreme they challenge the limits of our imagination and perhaps even reality itself. The hazards aren't just physical, like radiation or time dilation. They're existential, raising questions about whether the universe itself could unravel in the process. One of the first challenges we'd encounter is the nature of time and space itself. The deeper into the cosmos we travel, the more extreme the effects of relativity become. At relativistic speeds, approaching the speed of light, time for the travelers would slow down dramatically compared to those back on Earth. This phenomenon, called time dilation, means that while the journey might seem brief to those on board, thousands or even millions of years could pass outside the ship. Imagine leaving Earth to explore the universe, only to return to a planet that's unrecognizable, with everything you once knew long gone. And that's assuming you could return at all. Then there's the issue of radiation. The farther we travel, the less protection we'd have from the cosmic rays and high-energy particles that bombard space. Over billions of light-years, this radiation could pose an insurmountable challenge to both humans and spacecraft. Without revolutionary shielding technologies, the journey could be lethal long before we even approach the universe's edge. But the most mind-bending dangers come from the very fabric of the universe. Near the edge of the observable universe, space and time might behave in ways we can't predict. If the universe is expanding faster than the speed of light, as current observations suggest, any attempt to reach the edge could be like chasing the horizon, an unattainable goal that stretches further away with every step. And if we somehow manage to reach the limits of what we can observe, we might encounter phenomena that defy our current understanding of physics. Could the laws of nature themselves break down at the edge? Could space-time distort or collapse under the stress of our presence? One particularly chilling theory is the idea of vacuum decay. This hypothesis suggests that our universe exists in a metastable state, a kind of false vacuum. If we disturb the wrong region of space-time, we could trigger a chain reaction that collapses the universe into a lower energy state. This event, called vacuum decay, would propagate at the speed of light, destroying everything in its path. While this idea remains highly speculative, it's a sobering reminder that tampering with the cosmos on such a scale could have catastrophic consequences. Even the act of observing the edge of the universe could create paradoxes. If the observable universe represents a boundary defined by the speed of light and the expansion of space, then reaching it might fundamentally alter how we perceive time, space, and reality itself. Could we accidentally rewrite the rules of physics? Could our presence destabilize the delicate balance that allows the universe to exist as it does? These questions lie at the intersection of science and philosophy, challenging us to consider the implications of pushing too far into the unknown. The paradoxes and dangers of traveling to the edge of the universe highlight the incredible complexity of the cosmos and our limited understanding of it. Would reaching the edge reveal answers to the universe's greatest mysteries? Or would it create even greater ones? Perhaps the most profound question is whether we should attempt such a journey at all. What do you think? Is the pursuit of knowledge worth the potential risks, even on a cosmic scale? Let us know. And as we conclude our exploration, let's reflect on the incredible journey we've taken together. From the heart of our galaxy to the very edges of the unknown. Would touching the edge of the universe finally answer the question, why are we here? Imagine what it would mean for humanity to reach the very boundary of existence as we know it. Such a journey wouldn't just be a triumph of science or engineering, it would be a moment of profound existential reckoning. Standing at the edge of the cosmos, staring into the unknown, we'd be forced to confront the deepest questions about life, reality, and our place in the universe. For one, the discovery itself could redefine how we see ourselves as a species. Carl Sagan once said, "We are a way for the universe to know itself." Reaching the edge of the universe could be the ultimate act of self-awareness, a realization that we, tiny beings on a small planet, have managed to understand and explore the vast cosmos that gave us life. It would be a moment of unparalleled unity, a collective achievement that transcends borders, cultures, and histories. Or would it? What if such a discovery divided us instead? Historically, humanity has often responded to the unknown with fear and conflict. Would reaching the universe's edge lead to arguments over who controls this new frontier? Would it ignite debates about whether we should even go further? The edge of the universe isn't just a physical boundary, it's a philosophical one. It raises questions about ownership, responsibility, and the very nature of exploration itself. And what if, out there at the edge, we discovered we weren't alone? Imagine finding evidence of other civilizations, beings that had also reached their cosmic limits. Would we see them as friends, rivals, or something beyond our comprehension? Such a discovery could shatter our sense of uniqueness, forcing us to rethink everything we believe about life and its place in the universe. Or, conversely, what if we found nothing at all? What if the edge of the universe confirmed that we are truly alone, a solitary beacon of life in an endless void? How would humanity grapple with the weight of that isolation? Reaching the edge of the universe might also challenge our understanding of reality itself. If we discovered other dimensions, multiverses, or evidence that space and time aren't what they seem, how would that reshape our view of existence? Would we see ourselves as mere specks in an infinite multiverse, or as the lucky inhabitants of a unique and extraordinary universe? Ultimately, the journey to the edge of the universe is about more than discovering what lies beyond. It's about discovering who we are. Would such a journey make us more humble, knowing how small we are in the grand scheme of things? Or would it make us more ambitious, igniting a desire to explore even further, to push past every boundary, until there are no more limits to find? The edge of the universe isn't just a destination, it's a mirror, reflecting our deepest hopes, fears, and questions. Why are we here? What is our purpose? And what lies beyond the horizon of our understanding? Let us know what you think. Could touching the edge of the cosmos unite us in wonder, or leave us questioning everything we've ever known? Whatever the answer, one thing is certain: the journey itself would change humanity forever.